Hello guys, today we are going to discuss about the Digimat software. Starting with the basic thing that here's the Digimat software you can see here. So after double clicking on it, a window will appear like this. There are certain models that to be solved in the Digimat software. So our concern is related to the FE solver. So by clicking on FE solver, so a window will appear like this. So here is the basic window of the Digimat software. So to do analysis on Digimat software, so we have to add analysis by right click on Digimat, and here different options are shown. So we click on the add analysis option. So after it, here you can see there are the certain options that are visible here. So here in the analysis you can see that there is a name you can give assign to your simulations. That here I am writing as basic tutorial, and uh, here are certain different options that if we are solving on the Digimat software, so we have to choose the Digimat FE solver, in which the Digimat will automatically solve the simulation, perform the simulation. And but if you are just using the Digimat software to generate the geometry, and then you have to import this geometry to another software like Abacus, ANSYS or some other software. So just like that, in this tutorial I told you I will discuss about the that how you have to import your geometry to the Abacus software. So I select the Abacus from here, and here in the select method for FE model, so here are two different options. We are exporting our model in form of a script. So I select the export option of the export via script here, and after it go to the materials. There here shows the material one. I rename it as epoxy. You can take any material. There are some certain options here that your material is elastic, viscoelastic, hyperelastic. I prefer to do to remain as elastic here. And here's the symmetry, that is isotropic, transversely isotropic. So I just use the default option elastic isotropic here, and after it you have to click it on validate option. So here are some certain parameters that we have to assign it to our material of the epoxy. So here is the density. If you know very well about your material density, so you can put it up here, but I normally didn't select the I didn't give the value of the density here. So I just assign the value of the Young modulus and the Poisson ratio, that is 3 exponent 10, and I take the Poisson ratio to be 0.3. These are some random values that I taken up here. So after assigning the values of the Young modulus and the Poisson ratio, you just have to click the create button to create that material. Okay, so the one material is created here. So now if I'm adding another material, so how do you add it? Just select material, right click on it, add material. So here shows the material 2 option. So you can rename it as just like I gave the silica name here. The same elastic isotropic properties are remain same. Go to the validate option, assign the Young modulus value. Let's suppose 70 exponent 9. Poisson ratio you can take as 0.3 also. And after giving the values, then I just click it on create button to create the material of the silica. So here are two materials, epoxy and silica. Now go to the microstructure, and here comes in the face option. So you can assign the name here of to your microstructure, that I assign here as matrix name. And the phase name, phase basically I'm just creating two phase. The one is of the epoxy, which is the matrix, which is my matrix, and I and my silica, and my second material is of the silica, which I will use it as a filler material in the matrix of the epoxy. So I just give the name of the microstructure to the matrix, and phase name as for the first one is the epoxy. Here the default option will remain the same, as the phase type is the matrix, material is of the epoxy, and just click on the create button to create the face of the epoxy here. And now I'm going to add another face up here. So just right click on matrix, add face. So here is the phase 2. So I'm renaming it as silica, which is our second material. So as I told that I use the silica as a filler material, so I'm assigning the silica as in form of the inclusions. Okay, so that's why I click on inclusions. You can also add your filler material in form of voids, containers bar, yarns, etc., but I'm now selecting is at in form of inclusion. So click on inclusion. The default option will remain the same, or you just have to change the material type here, as here is the silica. Now validate it, click on the validate option. Here the system is asking you related to some other properties of the filler material, that here is the volume fraction and the mass fraction. So the software is asking you that what is the volume fraction of your filler material. Just like that, I'm assigning it up to a value of you can assign it in between 0 to 1, or the volume fraction of I'm giving here is around 10%. So 10% is 0.1. So I'm giving the volume fraction of this filler material. This is the matrix of the our material, that is of the epoxy, and here is the filler material, that is of the silica. So I'm giving the value of the volume fraction is to 10%. So the diameter of the silica filler material is like that, and if I increase the volume fraction to let's suppose 0.3, so the diameter of the filler material is changed. Okay, so that's how you can assign the different volume fraction, different percentage of the volume fraction to your filler material. So after it, I'm just renaming it to reassigning the value of the 0.1 to it. Okay, here are some certain options, that how many type of that this first of the number of inclusions will give you the value, that here is the 30 value, which shows that these type of the spherical filler material will have the value of the 30. Yeah, these are in the 30 number of inclusions. So you can change the number of inclusions. This is the number, this is the first inclusion, and these are like 30 inclusions in this matrix. Okay, so you can change the value of here, like let's suppose 20 or 30, or it's up to you according to your simulation. So it's 30. Also you can change the shape of your filler material from here, inclusion shape. So it's by default it's ellipsoid. You can change it to cylindrical as well. So the cylindrical form is here, and some certain other forms are mentioned here. So I use the default option, and here shows the aspect ratio. If you are changing the aspect ratio, so the diameter and the other things are also gets changed. So I just use the aspect ratio of 1 here. So also this aspect ratio will depend upon the number of inclusions as well, which change the diameter value also. Okay, so let's suppose the 30 value, at 30 number of inclusions the diameter is 0.185. If I increase the number of inclusions to 50, so the diameter of our filler material gets changed. Okay, so these are related to it. Here are some other options, you can go in depth of it. Okay, so just no need to change any other thing, and just assign the volume fraction here, the number of inclusions, that how many of the filler material you can fill your matrix by this, and you can change your shape of your filler material from here also. So after assigning these values, just click on create button here to create the silica face also. And here in the advanced parameter you can use clustering option, and also here the size of your RV is by default is 1 1 and 1, because the Digimat is the unitless software. Okay, you just have to consistent with your unit. Also the here shows the option of the filler material, that the sequential option shows that your filler material is distributed in a certain manner, in a particular distance, and all the number of inclusions were at the will follow the same distance or the same radius or any other dimension. But if you are selecting the random option, then all the filler materials will get randomly distributed throughout your matrix. Okay, I choose the sequential option here, and just create it. After it you can click it on RVE option. Here you can see that if you are using by default option, so the size of the RV, as I shown you previously, is 1 1 and 1, but you can define by your own way from selecting the user define option here. And let's suppose you can say that 100 100 and 100. Okay, and after assigning the value of your desired dimension, then you just have to click on create button here, and after it go to the geometry option here. So here in the geometry, here are certain options that are showing here. So my geometry is of the my geometric is periodic, so I select the periodic geometry option here, and these are all the default options. You just no need to change anything here, and just click the generate geometry button here. Okay, so it's generating here, so it's completed 100%. So that's how your geometry will be created in the Digimat software, as like here. These are the filler materials, and these are in number. These are there are 30 filler materials that are distributed in the matrix material here. There are some other options, other tabs here. You can select the RV global data here, that shows different options of your generated geometry here, that the number of inclusions there as the in highlighted in the red. These are in number of 30. So there are number of inclusions 30, the effective volume fraction, reference volume fraction. So number of options are here, the RV phase data. So no need to go in depth of it, just generate the geometry. So the software will generate the geometry like this. After it, you have to go to the mesh option here. So these are the default option of the mesh that the Digimat software use. So just click on apply option here, and the software apply the mesh on the generated geometry. Then go to the failure. No need to apply anything here. Loading, just go to the loading, mechanical. So here shows the boundary condition, as I have selected the periodic one. So you can change according to your simulation as well, but but in my simulation it's of the periodic geometry, so I select the periodic option, and that is the by default. And Digimat, leave it, and other thing. So here shows the loading type, that here the uniaxial one. You can select any other direction, that is uniaxial 2 in the second direction, y direction, and here in the uniaxial 3 in the z direction option. Okay, so I just use the by default option of the uniaxial 1 direction, and rest of the thing will remain the same. Just click on the validate option here. So a window will change, the tab of the second will open here, parameters will open here. So just leave it as it is, all the thing, and just click on the create button. Okay, so the mechanical loading has been applied here. Just click on next option, the solution option here, and no need to give anything here, no need to change anything here, as I in the beginning I said you that I am exporting this geometry to the Abacus software. So here is the shown that the export to Abacus option, and if I use the Digimat FE solver option, so the Digimat will solve your simulation here, but I have to export our model to the Abacus. So I'm just click on export option here, as my working directory is set in the Digimat basic tutorial. So I just click on OK button here, and it asks me to whether I will export this geometry to Abacus software directly from here or not. So I click on no option here, and I will show you that how you can export your generated Digimat geometry from Digimat to Abacus. Also, one thing, note that the Digimat will transfer your geometry in form of a script. Okay, so let me show you that how you can export your geometry, this geometry, to Abacus. So this is the Abacus interface. Just click on the file option here, click on here, different options are here. You can import, export, but for the Digimat generated geometry, you must have to click on run script option here. So I click on run script here. So I'm going to the file where I have saved it. Digimat basic tutorial. So I'm our analysis is of the basic tutorial. So this is in form of, you can see that it's in form of the py file format. So it's a Python script file. So click on this and okay. So the abacus will automatically import this geometry from Digimat to it here, as you are saying that it's reading the file, the Python script. So just wait for it while the abacus is working on it. So that's how the geometry is imported here. As you have seen that all the parts has been created here. The material is also assigned as in the Digimat, epoxy, silica. Also in assembly, instances also created here. Steps has been defined. The boundary condition has been defined here. Okay, so just you have to create a job here, submit it, and your analysis will run in that form. Okay, so that's how you can import your file, the Python script, from the run script option to import your geometry from Digimat to abacus. Okay, so the mesh option is also shown here, that is the generated mesh of the Digimat software. Okay, so that's how you can generate geometry on Digimat and import it to abacus. So thank you very much for the video.